Hello friends, continuing with applications of Gauss law. Today we take up third application, electric field intensity due to a uniformly charged thin infinite rod at a distance r from it. We have to follow 7 steps as usual. A. Identify charge. Consider a uniformly charged thin infinite rod having linear charge density lambda as shown. Consider a section of the rod of length L such that charge on it be say Q equal to lambda into L. Let us mark it as equation 1. So you look at the diagram. Here is the rod which is uniformly charged from minus infinity to plus infinity, and the rod is thin. B. Identify point. Let there be a point P at a distance r from the line of charge where electric field intensity is to be determined. C. Assume a Gaussian surface in the form of a cylinder of radius r and length L, whose axis is coincident with the rod itself, such that point P lies on the curved surface S3 of the cylinder as shown. D. Charge enclosed by the Gaussian surface, say Q, that will be equal to lambda into L. Let us mark it as equation 1, as previously we have marked it as 1. E. Electric flux linked with the Gaussian surface. Electric field at every point on the curved surface of the cylinder is same because of symmetry and is along the radius directed outward as shown in diagram. Now Gaussian cylinder has 3 surfaces, S1, S2 and S3. The total flux linked with the whole cylinder is the sum of the electric flux linked with each surface. The total electric flux linked with the cylinder would be say phi E is equal to E dot S1 E plus E dot S2 plus E dot S3. So this is how you can look at the dot products of the cylinder. Okay, cylinder has 3 surfaces, 2 cap areas and 1 curved surface. So accordingly we calculate flux linked with each surface and then we add them up. Now let us evaluate dot product. So total electric flux phi E would be equal to E S1 cos theta 1 plus E S2 cos theta 2 plus E S3 cos theta 3, where theta 1 is the angle between E vector and S1 vector, theta 2 is the angle between E vector and S2 vector, theta 3 is the angle between E and S3 vector. But theta 1 is equal to theta 2 is equal to pi by 2 and theta 3 is 0. You look at the diagram and mark the directions of E and S surface. Accordingly you will get the magnitude of angle. Therefore total electric flux phi E would be equal to 0 plus E into S3, and it is equal to E into S3. After substituting the values of theta 1, theta 2 and theta 3, we get the final result as total electric flux linked phi E is equal to E into S3, where S3 is equal to 2 pi r into L. Now since electric field intensity at every point on curved surface S3 is same because of symmetry, therefore total electric flux linked with Gaussian surface is phi E, which is equal to E into 2 pi RL. Let us mark it as equation 2. Now F, according to Gauss law, phi E must be equal to charge enclosed divided by epsilon naught. Mark it as equation 3. G. Electric field intensity. Let us calculate. Substituting value of phi E from equation 2 in equation 3, we have E into 2 pi RL is equal to Q by epsilon naught. Substituting the value of Q as equal to lambda L, we have E is equal to lambda L by epsilon naught, or we have E is equal to lambda by 2 pi R epsilon naught, which is the final expression for electric field intensity due to a line of charge at a distance r from it. Now discussion. Since electric field intensity E is given by the expression E is equal to lambda divided by 2 pi R epsilon naught. Now look at the formula. It reveals that electric field intensity, number 1, is independent of length of the charged rod. Number 2, depends inversely on the distance from the rod. Number 3, depends inversely upon absolute permittivity of the medium between the rod and the point. So remember these 3 points and it will help you in solving numerical problems. And now assignment 1.5 continued. Question number 21. Use Gauss law to obtain an expression for the electric field intensity due to an infinitely long straight uniformly charged wire. Question number 22. An infinite line of charge produces a field of 9 into 10 raised to the power 4 newtons per coulomb at a distance of 2 centimeter. Calculate linear charge density. Question number 23. Calculate electric field intensity due to a uniformly charged hollow cylinder of radius r, length L, having surface charge density sigma at any point capital R greater than small r, capital R equal to R and capital R less than R. That is, outside the cylinder, at the surface of the cylinder and inside the cylinder, where capital R is the distance of the point from its axis and small r is the radius of the cylinder. Question number 24. Calculate electric field intensity due to a uniformly charged solid cylinder of radius r, small r, length L, having volume charge density rho, at any point capital R greater than small r, capital R equal to small r or capital R less than small r, where r is the distance of the point from its axis. It means you have to find out electric field intensity outside the cylinder, at the surface of the solid cylinder and inside the solid cylinder. Okay, so this is all about this application. Tomorrow we'll take up the 4th application, where we will find electric field intensity due to a uniformly charged thin infinite plane sheet. Okay, thank you. God bless you.